10 million TV homes strong every single weeknight. 150 radio stations. Let's not forget Armed Forces Radio in 175 countries and all the ships at sea.
Love our troops.
Big Biz Show is on the air. Great to have you along today. Mike Costa in studio. Sully here, of course, the day trader Quattro. And very excited for our next guest. And his name is Les Goldman. And he has been a long-time contributor here to the program. He's Senior Vice President and General Counsel of Northwest Biotherapeutics. Their stock symbol is NWBO. You hear me talk about them almost constantly because it's one of those companies with their DC Vax technology and where they are in the clinical trial story. So Les, great to have you along today. Let's talk about this real quick. Can you give us an overview? Because GBM is a horrible disease. Talk about that.
It is the most lethal form, quickest growing and quickest killing of any solid tumor cancer. And solid tumor cancers make up about 85% of all of the cancers that we know about. So it's really important, but additionally, the platform that we've developed, which I'll explain the way it works in a couple of seconds here, because that's an important revelation that came from a presentation that Dr. Marnix Bosch, our Chief Technical Officer, made at a major conference just about 4 or 5 weeks ago. And what we discovered with a study called proteomics, which is the study of proteins. We've been studying the genome for 20 years. The genome is made up of cells, strands of DNA, which are made up of various components. Proteins are part of those components, many proteins in each strand, and each protein has individual parts of it that are called peptides, and that's a very small fragment of a protein. And Dr. Ralph Steinman, working at NYU as a molecular and cellular research doctor in 1993, actually, was the first person to identify what until then nobody knew what a dendritic cell even did.
Sure.
And what we presented just about 4 or 5 weeks ago confirms that it's a really unbelievably bigger thing than even our inventors realized at the time, which is it is basically, we'll put it in today's parlance, it's the artificial intelligence of our immune system, which has evolved over many years of human evolution. And what the dendritic cell does, Steinman won the Nobel Prize in 2011. It usually takes 30 years from your discovery but it was so significant that he won it in just about 18 years, 16 years, 17. And what it does, and what I'm going to explain to everybody after giving you just a little bit more background, is there are two components to making our vaccine. One is the antigens, which is the same meaning as a peptide that you find in your own tumor tissue. And we either get the tumor tissue by operating, if you can operate, or we do the same technique by putting our invention into the tumor tissue, doing in the body what we do in the lab. Well, let's just keep it separate for a second and talk about the operable approach. And if we've got time, we can touch on the inoperable approach, but it's the same principle. The dendritic cell is one of the components of the vaccine. The other component is the tumor tissue itself, treated in a proprietary way that we do, which breaks out all of the peptides that are in that particular kind of tumor. In this case, it's GBM. And in the lab, we do a blood draw to get the baby dendritic cells, and that needs to be fresh, so we try and get that done near one of the manufacturing facilities that we have, and expose the peptides that are in the tumor tissue to the dendritic cells. And here's where the magic starts. I mean, it's exquisite, it's elegant, it's non-toxic, and it works pretty well based on the results we've got. Now we have a better idea about why it works. What happens is when the dendritic cells meet these peptides that were in the tumor tissue, they select the ones to be targets for the weapons of the immune system. And listen to how this works. They choose the ones that are all relevant to that particular cancer, and they hold on to them on the surface of the dendritic cell. These are teeny things, understand? And then we take the result of that combination, which we do what I just described in the lab, where this selection process of the dendritic cells occur. Then that becomes the vaccine, which we ship to the doctor's offices, and the doctors give a shot right in the upper arm, right near your lymph nodes. And the reason for that is the lymph nodes are the conference center of the immune system. And what are these AI type, nobody ever heard of it millions of years ago as they developed, but whatever. What do? They carry on their surface these various targets, many more than anybody can think up in a lab, because it knows when it sees what was in the tumor tissue what to go after. And it presents those to the weapons of the immune system. And because this is elegant and complicated, I'm just going to focus on one of the best weapons in the immune system, called the T cells. And what it does is it hands off in the conference room, in your lymph nodes. It says, here are the targets for you to go after and identify and find these in the body, and then go attack them and kill them. And not only does it present these targets, before we did this, we knew there were maybe about 35, 40 of the antigens out of 50,000 in the body that needed to be identified. The dendritic cell figures it out, it mounts it outside of the cell, holds onto it, hands it off to the T cell, and the order to the T cell, and this is just one of the many weapons in the immune system, all of which are organized and given orders by the dendritic cell, thank you, Dr. Steinem, go get them, boys. And not only do the T cells pick up all those targets and now go hunting for them in the body, that'll be the cancer cells, but they are also encouraged to multiply, to clone, to create more of them as they are loaded. And one of the findings in his proteomic studies was that normally in the human body, if you're healthy, you'd have something like between 5 and 20, as you measured in a volume of blood, of these T cells. After 4 months of the vaccine being administered, it's like halfway through the full regime, which is 6 shots in the first year, it was discovered that the cloning of that original 5 to 20 had resulted in 400 new T cells that had multiplied from the base. So not only are they going after numerous targets, but there's a whole bunch of them that are doing the same thing. And that accounts for the fact that everything else on GBM has pretty much failed, adding just weeks of toxic life. And our vaccine is non-toxic because this is nature's way of handling it. And we're just re-educating the immune system by getting on the back, if you will, of the dendritic cells and utilizing them to go tell the immune system, the killer cells, the T cells, all of it, what to do. And the amazing discovery is how viciously they're doing it when it comes to just following their orders. So now, that tells you how it works. And it's almost like before we had a black box based on Steinman's invention, and now we know how it works and why it's better than anything else out there.
So Les, my question is, based upon it being a vaccine from your own immune system or your own cells, Is it possible that this could be a therapy for other cancers because the way it multiplies and such? Is it specific to GBM? Is it possible that it could go towards other cancers?
We've already shown it to work in the compassionate treatment specialist program that we are currently running in the UK, and it's building up. But we made it work on 15 different solid tumor cancers.
Wow.
Most of them blockbuster drugs.
Les Goldman's with us, Northwest Biotherapeutics. He is the Senior Vice President, General Counsel. The company's obviously something we've been covering for a long time. And they're at the tip of the spear here on cancer therapies, especially with GBM, horrible brain cancer. You can go to nwbio.com. Their stock symbol NWBO. More of us is coming up.